you're going to be making a basketball game. And you'll see the goals here on this picture, and we'll talk a little bit more about it, but you're going to have to modify a robot in many ways, which means you're not going to be able to use the Clawbot program that we've been using, and you actually have to do some programming. We'll get to the programming later, but let me just quickly introduce this. You might remember the Lego movie.
Sorry, Street. I can see everything. What the heck is this? I am a master builder. Release every micromanager we have. Let's get it, fellas. Hey, everyone. Lucy, I'm going inside that thing.
You got it, Emmett.
Take it. Good night. Come here. We'll help you out, kid. Here's how we do it. Pirate style.
Emmett, that's it.
You might say, why am I showing the video? The answer is you're now officially all master builders. You know how to build a basic robot. And so now you're ready to go ahead and modify your robot to solve a more advanced problem. Here's the actual game itself. You're going to be assigned either the red corner or blue corner. And with your existing claw, you can take the balls from here and actually take them over to your goal and easily put them into the 2-point basket. Each time you put a ball in there, I'll roll it back over to this corner again. If you're on the other side, you'll be rolling them from here and putting them into this one. Each time you get a ball in, you'll get 2 points, and then I'll return it back to the corner. But the challenge on this one, and either side can go it, if you can get one of the balls into this 5-point basket, you can rack up points incredibly quickly. Now, to get into that, you're going to have to actually modify your robot because your claw right now will not be able to reach that basket. The rules for it are you can't topple over the goals, and you've got to be placed, the balls have to be placed in upright goal, and you're not allowed to interfere with the other team. You're both sharing the same tall 5-point basket in the center. How do we modify
You
our
may have
robot?
thought, hey, I just want to...
Well, one of the ways is to actually use or extend your arm. And I just want to show this real quick how you can do that.
You may have thought, hey, I just want to have something move straight, but I can't use pneumatics. Or, I need more reach, so I'll just use these linear slides. Well, I thought this, but when I went to go assemble it, I realized that the screws that attach the gear strips to the slides interfere with the screws needed to attach the slide holders to your structure. Well, after some thought, this is my team's solution to the problem. Okay, listen, that was past me. I'm interrupting this admittedly fairly nice video, if I do say so myself, to tell you that the way I was going to show you is not the best way. I was going to show you a way that involved drilling and using aftermarket nuts, but through the magic of online forum technology, I have learned that that was not the best way to do this. Here is the best way that I have found so far. These slide holders can be, when screwed in from the other side, attached with normal size screws. Just pop 2 screws in to attach the slide holder to the bracket and you are good. Next, pop a bearing in between the motor and the bracket using the long motor screws. Pop another bearing across from it. This helps to stabilize the gear and put less strain on the motor. I used a high-strength 36-tooth gear sandwiched between 2 size 2 spacers to drive the linear slide, using 2 shaft collars to hold the shaft in place. After tightening these 2 shaft collars, you could add another one on the other side, but it's not super necessary. Trim the shaft if you want, and there you go. You have your linear slide. I hope you enjoyed this video, and if you want to see more robotics and electronics content, be sure to subscribe. Thanks for watching.
So one option is actually adding a linear extender on your claw. We've had groups try this. Some have been very successful. Others have had major problems with it, but I wanted to show it to you. The other
The V5 pneumatics kit has features that can enhance
pneumatics. Pneumatics, in this case, you're going to use pressurized air on your robot, and you can have extenders on it. And I just want to show it to you real quick.
The V5 Pneumatics Kit has features that can enhance your robot's design and performance. Let's take a look. The kit includes an air pressure gauge that can be mounted to your robot or directly to the 200 milliliter air tank. The air pressure regulator can be adjusted without the need for additional tools, giving you full control over the pressure through mountable double-acting solenoids. This kit also includes a tubing cutter, whose purpose unclear. Our innovative push-to-connect fittings have built-in gaskets and uniform thread size, eliminating the need to seal your fittings with Teflon tape, making any of these fittings rather fitting. Our cylinders come in 3 different sizes and thread into all existing VEX hardware, making the use of pneumatics easier than ever. Visit v5.vex.com to order your V5 Pneumatics Kit today.
Silly.
You can think about pneumatics either for raising your arm or for running your claw. It is much faster than using a standard motor. If you want to do that, we'll talk more about it. We do have pneumatics sets, and we can actually modify your robot. The simplest method of all, of course, would simply be to lengthen your arm. That is possible, although you'll probably need a little bit more force to be able to lift it, which means you'll probably need to change your motors just a bit. The programming bits, it turns out, in this case, we are going to actually use the laptops and VEX V5 coding. And there's some templates already built into it, which makes your life a little bit easier. In this case, if you start out with the Clawbot 2-motor, no gyro, that's basically the code that we were using for your existing Clawbot. So if you open that up, and we're doing it again in C++, we're not doing it in Python, we're not doing it in blocks. If you choose that, you'll actually get to see the code. And then up on top of your computer here, we're going to actually assign whatever motors you have. So for example, up in the top corner, you'll see this little icon right here. If you click on it, it'll expand the various motors and types of things that you can plug into your brain, and you'll see a bunch of them. If you want an example, one of the first things you're going to probably choose is, if it's not already there, your drivetrain with 2 motors. And it's going to ask you, hey, what ports are your right and left motors plugged into? But then, for example, if you're going to add a motor, you can click on that. You can also choose 3-wire options. The 3-wire options give you a whole bunch of other options, servos, digital in, digital out. But if you're using pneumatics, we'll use digital in and digital out to control those. And you can actually specify, hey, I'd like to use pneumatics, and the pneumatics is going to be connected to port A. Port A is one of those little 3-wire ports on the outside, ones we haven't used yet, but that's the ones pneumatics would use. And then you can specify, if you click on A and say done, you'll see over here in devices, you'll see your drivetrain with what ports the motors are plugged into, your claw motor and what you define that, the arm motor, the controller, and then the lift, which we just defined as A. You can add as many devices as you have ports. Just don't go too crazy on this one. In this case, we're choosing digital out if we're going to use pneumatics. The next step on this one is, oh, sorry, I actually circled it. You'll actually need to modify the code a bit. If you look on the controller, you'll see that there are literally little things or letters next to each one. One of the things you're going to need to do, though, is add some code here in main. Main is the main part of our code, and we're going to set stopping to hold. And you might say, wait a second, what's hold? Hold means when you let go of the button, the motor's going to try to keep it there, which is why, for example, if you let go of your arm raise and lower buttons, it stayed at whatever height it was. That's because it was literally sensing the motor and making sure the motor didn't drift down or drift up. So for example, let's say we wanted to actually connect the lift pneumatics to button A. And so you can say something like this: if controller1.button A.pressing, that's either true or false. If it's true, it's going to turn on that lift digital output. Else, it's going to turn it off. And that will literally control the pneumatics. You're like, wait, that's pretty simple. And as you type this code in, and we're not going to do it this period, but when you get to it, as you start typing this in, it will actually automatically start filling in the code for you, which is so friendly of it. We can go a little bit further as well. You could even do this where you set it to different ones. So for example, when you press A, it sets the lift high or true, and it actually raises it. If you press button B, it sets it false and starts lowering it. And so you can actually specify which buttons on the controller you would want to use. I don't necessarily recommend this one for pneumatics, but you could define it this way. What about adding motors if you wanted to use some extra motors to do it? Like, for example, an extender motor if you wanted to do the linear extension. Well, for that, you can simply go and choose a motor. You can name it anything you want up here. I'd recommend naming it something logical. You can specify which of the 3 transmissions, red, green, or blue, you have in it, and whether you want to spin normal or reverse. Some of you wanted to actually reverse your motors, and you're like, how do we do that? And the answer is with coding. And then when you say done on this one, you can actually see it over here. You've got extender motor, and I chose that I was going to plug it into port 20. And now we've got our lift plugged into digital port A, our extender motor plugged into port 20. And now we can actually modify that. Again, I'm going to say the extender motor, I'm going to add hold on it so it stays where we leave it. And I can simply say this. If button A is pressed, spin forward on the extender motor. If button B is pressed, spin in reverse, which means it's going to pull backwards. And so you can literally just do that, and now you've got those extra things. You're like, wait, do I have to program the whole motor stuff and the controller stuff? No, that's the beauty of this. The code actually, all you need to do is add it inside of main, the additional things you want your Clawbot to do, since we start out with the Clawbot template. And hopefully that makes some sense. That's actually where I want to stop today. Your goal today is simply to build the robot. You don't have to do any coding yet, but start doing some design work. You can start thinking about how you're going to get up to that tall goal. With that, good luck. I'll see you next time. Have a good night.